All right, we're back. We're still on page 191, math analysis. We're doing parametric equations. So far, we've dealt with, we're talking about circles. We've talked about circles where there are no additional directions. It's just like write me parametric equations for a circle. And so there's like not a lot of direction. So we have free range. If you are allowed to choose, you should always make x go with cosine, y go with sine, make both of them positive, and you're always going to start at the right-hand corner of whatever corner of a circle is the rightmost point. And then you're going to go counterclockwise. If no additional directions are given, that's what you should do. What if you are given additional information? So perhaps we want to change the speed at which you go around, right? So our choices of x is cosine, y is sine mean it takes 2 pi to get around the circle. What if it's some other amount? What are we going to do? Well, let's start to investigate that using things we know, right? So we know how to deal with the equations of sine and cosine. If we could draw graphs of the component functions, we could figure those out because we've done that a lot. I think in notes 5, perhaps. Power out again. Or is it just a flicker? Did I lose? I didn't lose internet. Okay, so this should still be working. All right, so we're going around the origin, constant speed. So we have to go to constant speed. The velocity is going to change because the direction changes, but the speed will be constant. That's the magnitude of velocity. So that doesn't really matter for our course all that much, but I think I should mention it because if you're super into this stuff, you'll immediately pick up on the fact that like, wait a second. So we're going to go to constant speed, not a constant velocity. I'm going to just draw. So let's see. So that's interesting. I don't know how I managed to break that line into 2. Like I didn't think that I had picked up my my pen or my marker or whatever. All right, so a circle. I'll just draw a circle, and then well, that's not even a marker. I got to tell you, like working on this during this storm. There's a big storm. I don't know if I mentioned that. Honestly, I don't even remember. Oh yeah, the power flickered. Oof. It doesn't put you in the right state of mind. I'll tell you that much. All right, we're gonna start at -8, 0. That's here. We're here at t equals 0. At t equals 6, we're at 0, 8. So we're up here. And now let's just note t equals 6, man. All right, let's assume that that's the first time we get there. We didn't do some crazy thing where we went all the way around the circle and then another quarter of the circle. So 5/4 of the circle would take you 6, and then you solve, which you can do. But we don't want to do that. That's too much for now. And so let's say we must be going this way if that's what has happened. So then if we're going at constant speed, we'll get here at 12. We'll get here at 18. And then we'll get back to the start at t equals 24. So it's going to take us 24 to get all the way around. That's going to be relevant to the equations that we write. Now let's focus in. So this is -8. It's going to be 8, 8, and -8. Let's do x of t, and then we'll do y of t. Okay, so this is going to be our t-axis, and this is x, because we're doing x of t. All right, when t is equal to 0, x is -8. So we're starting down here. Starting at a minimum, you already know it's negative cosine. Negative cosine is the trig graph that starts at its minimum, but let's continue. At t equals 6, and then 12, and 18, and then 24. All right, at 6, we're going to be at 0. At 12, we're going to be up at 8. So this is only confirming what we thought we knew. So you can fill those in. Then I find it easiest to not use a continuous thing, but instead do each of the segments, whatever. All right, so if I had to write the equation of this, I would say that x is -8 cosine of what? All right, so the period is 24. Where am I doing this work? I'm going to move this down and do the work up here. So the period, because it takes 24 to repeat, is 24, which is 2 pi over b. So b is pi over 12. Pi over 12 is actually a really common value for p. You can probably guess why. It's because a day has 24 hours. So anything that happens like on a daily basis, if it's cyclical, sinusoidal, b is going to be pi over 12. Pi over 12 t. And I'm going to move this back so it's like in a reasonable spot. Now let's do y. So if x was cosine, you know that y is going to be sine in some way. So really all we got to do is figure out like which sine, t and y, and it's the same basic setup, I guess. 6, 12, 18, 24. So the speed at which you're going around the circle is going to have to do with the period of the component functions, right? If the period of the component function is 24, it's going to take you 24 to go around. If the period of the component functions is 100, it'll take you 100 to go around. You just got to work it out or be told, or like it's always there. You can work it out. So y starts at 0, goes up to 6 to 0. So 0 up to 8 rather. It gets to 8 at t equals 6. Confusing things. Here to here to here to here, and then we go like this. So like we kind of already knew this. So b is going to be the same. So this is y equals positive 8 sine of pi over 12 t. So overall, our parametric equations are x is negative 8 cosine pi over 12t, and y is positive 8 sine pi over 12t. So that's going to work, I think. What I'm going to do, let me answer this next question, and then I'm going to go to GeoGebra, make it happen just so we can watch it. So in order to change the amount of time it takes to go around a circle, you have to change the period. So I'm gonna highlight that, and then I'm gonna say, therefore, change b, right? If you learned these the way that I teach them, it's the coefficient of t or the coefficient of x usually, but t in this case. Change the period of the components. Component function. So yeah, I mean, I think that makes a lot of sense. Like you're changing how fast it's graphed, so it should change how fast you move. Makes sense. All right, let's try GeoGebra, and I'm just gonna graph it. I'm gonna make it move, and then we'll go from there. Hold on. First, I'm gonna close my email because you don't need to be seeing that. I was actually just reading. I don't even know. I'm reading about AP Calculus practice exams that people are making. Fun. All right, because I got to worry about AP Calculus too. There's just so many things. All right, here we go. We're going to do curve, and it's going to be negative 8 cosine of pi over 12 t, comma, 8 sine of pi over 12 t. T is going to go from 0. It should be 0 to 24, right, if we're going to see the whole thing. So 0 to 24. Let me zoom out. This certainly looks correct. Now, what if I only grab 0 to 12? So 0 to 12 should only give me half of the circle. And it does. What if I go like negative 6 to 6? So start thinking about these things. Negative 6 to 6 is going to give me half a circle again because that's 12 and it takes 24 for the full thing. Like, where's that going to start? Where's it going to stop? There you go. It's that other side. So these are changes we can make. I'm going to change it back to 0 to 24. And now I'm going to put a point on it so that we can make it happen. So I'm going to do A of V, press enter, V becomes a slider. Change your slider. You need to go 0 to 24. I'm going to go, I'll go 0 to 48 so that it can just like go around and be fun. I'm going to drag you back to 0 and then animate. So at 0, we are here. At like 6, we're at the top, which is where we should be. We're going to make it in 24. So we did it. I highly, highly encourage you, basically everything you do, especially if we're doing distance learning right now, which I don't know what we're doing, but I mean, you're definitely doing that because you're watching this video. Everything you can, try to make it happen in GeoGebra. If it works after you've written everything, it must be right. So even if it doesn't match what I put, now the question becomes, why is what you did equivalent to what I did? You know, and that can happen too. So the more you learn, the more you practice, the better you'll be. So I'm going to end this video here. I will come back in the next video and keep going. So we got through this page. The wind, I don't want to like jinx this. It seems to be dying down a little bit. I really hope that it is because it's very scary. But anyway, I will see you in the next video, and yeah, see you there.